All right, let's get the show started. Hello, everyone. Thank you all for joining. Welcome to In Rhythm Lightning Talks. I'm your host, Parag Katkar. I'm the head of consulting practices at In Rhythm, and we have several awesome lightning talks lined up for you in the upcoming weeks. Our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time, and each week, one of our practice area consultants shares their knowledge on the evolving technology trends in the industry that will help you keep learning and growing in your career. So this week, Daniel, who is a lead iOS engineer with us, will be talking on async await in Swift. And as you know, last year WWDC introduced the new concurrency system in Swift by using async await syntax, and it's a huge improvement in the way that asynchronous code is written. I've been really looking forward to this talk. So without further ado, let's get it started, Daniel.
Okay, thank you. Um, so as has been said, I'm Daniel Steward, and I'm a lead iOS engineer here at InRhythm, currently working to help migrate Fidelity's youth account features into the new architecture. Um, I would like right away to make some call outs. First, thank you to Austin Michael for talking me into doing this. He's been a huge help, kind of pushing me along and helping me have a polished presentation, I hope. And if not, you can just blame him. And then, the other person I would like to call out is Michael Bickerton, a new hire. Who helped me out a lot by proofreading my presentation and calling out a few small errors here and there, which I was able to fix. So this is a talk about a portion of the new concurrency language features that Apple introduced into Swift just last year. And for those of you who aren't Swift developers, next time a Swift developer waxes poetic about Swift or concurrency or whatever, hopefully maybe you'll have a bit better understanding of why. This is a neat language and something that I certainly enjoy doing. And then lastly, a disclaimer, lightning talks are really meant for a broad audience, and so I've taken some artistic license here to illustrate the points rather than trying to teach Swift coding. So I'll move on. Oops. Why am I? There we go. A main problem that we have in all programming, this applies to Swift, C, C++, Java, you name it, is concurrency, things happening at the same time. And specifically, making sure that we can arrange things so that things that are happening at the same time happen when we want them to. So using the results of asynchronous threaded function calls is hard because you have to wait. And waiting in code is an awful lot harder than one might think. So how do you know that an asynchronous function is done, for example? How do you make execution of the calling function stop while other things continue to run? How do you restart execution of the calling function once things that you're waiting for are there? What happens to other operations on the thread's queue? Do they stop too? And all of these have been addressed to some extent in Apple's new concurrency code. So in this lightning talk, I am going to first show you how code executes in both an old completion block-based scheme side by side with the new async await-based scheme. And then I'm going to show you some actual examples of code to kind of give you an impression of just how different async await is and how much cleaner it is. So, and this is just simple pseudocode, nothing technical here. So we begin in a function where we've got some variables that we're going to set up at the top, and then we've set up some kind of, in this case, a dispatch group where we're going to enter the dispatch group for each thing that we're going to fetch, and then leave it again when each thing is done fetching. Okay, and so in any concurrent code, this first bit happens really fast, right? You start all these things running as indicated by the little clocks, and so on the left we've got fetch A returning something into a callback block, fetch B, same thing, fetch C, same thing, and then on the right we've got our async await code, and you can see that that's much simpler. We're just saying variable A equals await fetch A. Okay, so then of course things start coming back, right? These functions were all called on a background thread. They go off and do their thing on the internet someplace, and sometime they come back. And so variable B got set. Variable A got set. Variable C got set. Now,
wow.
At the bottom, and
wow.
so, thank you. And so at the bottom of this code, we've been waiting. Okay, so on the left side, this dispatch group is wait is a blocking function. It stops this thread from executing until conditions are met. In this case, no more groups are active. And on the right, we just block at do something with A, B, and C because those things weren't there yet. And then when they are there, we unblock and do something with A, B, and C, and we're done. Okay, so the next few slides are really not meant to teach you about coding. It's just an illustration of what this code looks like. And so you can see that in this case, a fetch weather function returns a result on a block, and it's fairly messy, right? We group enter at the top, group leave inside the block, group wait below. So this is all the same stuff that I just showed you. And then at the bottom, we execute on a main thread, setting the weather type, which is just a label. Okay, so here's the same thing using Combine reactive programming. And you can see that here again, it's just a closure at the end of the day. And in this case, we set a sync on a publisher, and eventually that returns and we get a result and do stuff with it. And down below, again, we had to do a group wait. And then we, on our dispatch queue main, we set the weather type. All right, so hold on to your seats. That's all of our async await code. We have one line of code replacing all of those other lines of code that just awaits the results of fetch weather. And when those results return, we execute the rest of the function. This is why virtually every Swift programmer I know is really excited. This next slide is just an illustration of one of the tools, because the question, of course, is, well, how do we write our own async functions, and how does that tie in with the block or combine based function calls to URL session and that kind of thing. And the way we do this, Apple, as part of their as part of the code for doing this, has supplied us with something called continuations. So in this case, I'm using a with check throwing continuation. And this essentially sets up a blocking function with a callback routine that we fill in where we fetch our results the way we were before. And then when we've got a result, we either resume the continuation, throwing an error, or resume returning our weather. And this is all pretty straightforward. Just a few little gotchas like weather API cancelable needs to actually be on the class so that it doesn't go out of scope, and some silly little details like that. But basically, this works quite nicely. So a question that has come up over and over, and a lot of conversation about it on various threads out there is, does this mean Combine is dead? Because it really does replace some things that we do in Combine. No, Combine isn't dead. While it's true that async await provides a cleaner, more readable way to wait for data that you need in order to perform other dependent operations, there is still a need for the functional reactive capabilities of Combine. More importantly, Combine's reactive publisher observer nature forms the foundation for Swift UI's ability to tie UI state to model state. And this really is no small thing. I don't know how many of you might have started out as Mac developers, but that's where I came from. And on the Mac side, we've always had something called bindings, which allowed us to tie user interface state like labels and button titles and things like that directly to modeled state, and without any glue code. And this was a big deal, and I've always missed it working in UIKit, but Swift UI and Combine bring that back, which is really nice to see. The relationship between Swift UI and Combine eliminates a mountain of buggy glue code in the typical UIKit-based application. Combine's reactive programming is still very valuable in the fetch functions we will write to get data from service APIs, but the ability to write an async fetch function eliminates the need for completion closures to return data. Which makes the code a lot more readable and easier to follow. So in conclusion, Async Await adds a much anticipated and needed tool to the Swift developers toolbox for handling the tricky problem of synchronizing functions that are dependent on asynchronous functions. While we've been able to handle these problems before Async Await, we now have a language feature that makes the code cleaner and easier to read and understand. Async Await does not replace Combine and does not address other threading issues such as race conditions, which we heard about in a previous talk, or deadlocking. For that, you'll all have to await the upcoming talk on actors, which is another component of these new features. Some useful links, and they're all Apple. So appledeveloper.com has a news link that does a really nice job explaining the basics of concurrency. And then, of course, the Swift language guide, which everybody should be familiar with, which has a new section on concurrency as well, which goes into great detail on not just async await, but there's a lot of nuances that I haven't mentioned here, and so that's a good place to go looking. So I will open it up to questions.